Hello dear students, today we are going to look at probability. We are going to look at a case where we are given two bags and then we are going to pick without a replacement. It is also another case we are going to look at. Also, we are going to look at ways of forming a distribution. Question: two bags A and B contains similar balls. Box A contains 3 red and 5 blue balls. Bag B contains 4 red and 7 blue balls. A bag is first picked at random and 2 balls are removed one at a time without replacement. The probability of picking box A or bag A is 3 times as B. Required: 1. Find the probability that the 2 balls picked are of the same color. 2. If X represents the number of red balls, form a distribution of red balls. 3. Find the expected number of red balls to be picked. Solution: they've told us members that we are going to first pick a bag. After picking a bag, we are going to pick a red ball and a blue ball. Therefore, we have 2 bags, bag A, and they have told us that in bag A we have 3 red balls and we have 5 blue balls. So if we get the total of red balls and blue balls in bag A, it is 8. In bag B, we have 4 red and 7 blue balls. If we add them, we shall get the total as 11 in the table. And the question told us that, the examiner told us that the probability of picking box A is equal to 3 times the probability of picking bag B. We shall model our statement in that way and we shall have equation 1. From theorem, we know that the total probability is 1. Therefore, don't forget it, i.e. the probability of picking bag A plus the probability of picking bag B is equal to 1. From there, we shall generate equation 2. Note that we need to find the probability of picking bag B and the probability of picking bag A. So we shall get equation 2 equation 1, we substitute it in equation 2. We shall have 3 probability of B plus probability of B, we shall get 1. So we shall generate equation 4. Equation 4 will take us to equation 5, and if we solve equation 5, we shall have the probability of picking bag B. From there, we shall get that probability, we substitute it in equation 1. If we substitute, we shall get the probability of picking bag A as 3 out of 4. Good. We shall draw our tree diagrams. Remember, for the first time, we have to pick a bag. Then we pick a first ball and a second ball. As you see on our tree diagram, we shall either first pick a bag when it is A, and we can pick a bag when it is B. The probabilities of picking bag A, we say that it is 3 out of 4, and the probability of picking bag B, it is 1 out of 4. That is the chances of picking a bag. Now we are going to pick a first ball. Remember, we can start from bag B. We can either start from bag B or from bag A. Let us start from bag A. In bag A, we have 3 red balls and 5 blue balls. Now, out of the 8 balls, we can have 3 red, and out of the 8 balls, we can have the 5 blue balls. We can go to bag B. Chances of picking a red ball from bag B, it is 4 out of the 11 balls. And the probability of picking a blue ball from bag B, it is 7 out of the total of 11. That is the first ball. And the question told us that we have to pick without replacing. Therefore, we pick a ball. After looking at it, we throw it away. For the second ball, we can go and pick from the line of red. We shall have 2 out of 7. That is red. For blue, we shall have 5 out of 7. Good. We can go to blue ball. We pick 4 out of the 7, and we shall proceed as you look at the tree diagram. The question told us to find the two balls are of the same color. If they say that the two balls are of the same color, what we have to note is we have to first pick a bag, then we pick the first ball when it is of the same color and the second ball when it is of the same color. For example, when we look at our tree diagram, on the right we have the sample points. The first sample points of ours, it is probability of picking the first bag when it is A times the probability of picking a red ball times the probability of picking a red ball. What does that mean? The first ball is red and the second ball is red. Therefore, that is the same color, which is red. Also, we can move at the downer part. Probability of picking a bag B. The first ball is red and the second ball is red. Also, the first ball is blue and the second ball is blue. So we look at the sample points, then we take those outcomes where we have a bag, a first ball, for example, red, and the second ball is red. Or a bag, a first ball is blue and the second ball is blue. So we shall go to numerical computation, probability of getting the same color of balls. This is what we have. We can first pick a bag when it's A. We pick a first ball when it's red, a second ball when it's red, plus the probability of picking bag A. The first ball is red times the second ball is red, plus the probability of picking bag B. The first ball is red, the second ball is red, plus probability of picking bag B. The first ball is red and the second ball is red. Students, if we look at that, we have a red ball, two balls of the same color. Blue ball, two balls of the same color. Therefore, we get the corresponding numerical values and we just substitute. After substituting, we have 3 out of 4 times 3 out of 8 times 2 out of 7 and others. I'm explaining why we are multiplying probabilities. It is because the cases are independent, i.e., the probability of picking a bag A, it is independent of picking a red ball. Or the probability of picking a first ball is independent of picking a second red ball. That's why we multiply the probability. And after doing that, those are the values we substituted to 2 decimal points, and the final result is 0.75. Part 2, distribution of R in brackets red ball. Remember, we can pick when the first ball is blue, the second ball is blue. So if we pick that one directly tells us that there is no red ball. Therefore, for 0 red balls, our x will be 0. P of x is equal to 0 is the same as probability of picking the first bag when it's A times the probability of picking the first ball when it's blue times the probability of picking a second ball when it's blue, plus the probability of picking a bag B times the probability of picking a blue ball at the first time and the probability of picking a blue ball at the second time. For that scenario, we shall not see any red ball. That's why we said that x is 0. We put in those numerical values from our tree diagrams and the answer is 0.36 to 2 decimal points. For one red ball, x will be 1. That one means that we can pick two balls, for example, a blue ball and a red ball, or a red ball and a blue ball. For that case, therefore, we shall have one red ball. And P of x is equal to one red ball. It is the same as saying the probability of picking bag A times the probability of picking a red ball for the first time times the probability of picking a blue ball for the second time, plus the probability of picking bag A times the probability of picking a blue ball for the first time times the probability of picking a red ball for the second time. Therefore, we shall see that at any point we have a red ball, a blue ball, a red ball, a blue ball. Therefore, a red ball is always occurring once. After putting in the numerical values, the value obtained is 0.53. Let us proceed, students. I hope that you are understanding. Yes, I hope that you are understanding. In case you see that something is not moving on well, you can just move behind and you play the part which you've not well conversed with. We have to pick the two red balls. Now for two red balls, this is what we expect. The two balls, the first one and the second one, they are supposed to be red, i.e. we are going to pick bag A. The first ball is red and the second ball is red, plus the probability of picking bag B. The first ball is red and the second ball is red. There we shall not see any blue ball occurring, and that one will give us a value 0.11. If they tell us to form a distribution, this is what they tell us: to find the x and the corresponding probability. Remember, for the first time when we are calculating no red balls or x is equal to 0, the probability was 0.36. For one red ball, the probability is 0.53. For two red balls, the probability is 0.11. People, that is not sufficient that we've formed our distribution. There are underlying conditions for probability distributions, as we are going to see. Proof for the above distribution: 1. It should be non-negative probabilities. If we say that non-negative probabilities or non-negative condition, we mean that the probabilities should not be negative. They are supposed to be positive. Look at our table. For x is 0, the corresponding probability is 0.36. Therefore, it is positive. For x is 1, the corresponding probability is 0.53. For x is equal to 2, the corresponding probability is 0.11. Clear? So it is non-negative. That first condition is fulfilled. 2. The summation of probabilities must be 1. The total probability is 1 from theorem. Therefore, if we get 0.36 plus 0.53 plus 0.11, those are the probabilities in our distribution of red balls. If we total up, we shall get a value which is 1. Therefore, the second condition is fulfilled. Students, if you see that one, it would automatically tells you that is a proper distribution. Therefore, it is fine. That one is done. Let us go to find the mean. The mean, it is summation of all x, capital X times the corresponding probabilities, which is equal to, when x is 0, it is 0 times 0.36, plus when x is equal to 1, it is 1 times 0.53, plus when x is equal to 2, it is 2 times 0.11. If we calculate that one, we shall get the answer as 0.75 as our mean or the expectation. Students, thank you for watching. If you see that there is something which you need to inquire, you can call my phone on the screen, or you can even WhatsApp me and we talk. Don't forget to subscribe my channel, or you turn on the notification such that in case there is a new word of thought, you can get into touch at a cheaper time. Thank you. I remain teacher Brian Sekate.